we are given this differential equation, another slope field that we're not even going to draw on. It's there if you want it, just for fun. I think there are a few things that will help us though, and as I glance through these and we talk about quadrant 1, quadrant 4, all these kinds of things, it's just handy to have this floating around. This is positive, comma, positive. Obviously you know this, but it's just going to be fun to look at and point. Well, it looks like a face with her eyes closed and no mouth and a slanted nose. So it doesn't look like a face at all. There we go. So we want to describe the behavior of the slope in quadrant 1. So y is positive and x is positive. X and y are both positive. So if I have a positive plus 1 squared, I have a positive divided by a positive. I'm going to get a positive. Well, can we just go ahead and point out something else that's obvious? This entire numerator, you're going to square it. We're not playing with imaginary numbers, so this is going to always be positive. That's just good to know. Numerator will never be negative. It just won't. So we're going to describe the behavior of this in quadrant 1 where we have something that's always positive divided by a positive x. That's what happens in quadrant 1. So we're going to have a positive slope. I'm going to say that dy dx is greater than 0. That's a fancy way of saying slope is positive. Okay, let's describe the behavior in quadrant 4. And again, we're in the same kind of situation. You guessed it already, I hope. And if not, that's fine. My y's are negative, but really who cares? Because you end up adding 1 and then squaring. Squaring makes it positive. So we have a positive divided by a, let's see, my slope that has an x in the bottom. Sorry, my mind just shut down for a second there. My slope has an x in the denominator. So that means I'm going to have positive divided by positive. My x is positive in the denominator. All right, there we go. My brain just rebooted. It's positive is what I'm trying to say. We have positive divided by positive. There you go. For what x values is, x and y values, is this positive? Okay, so we've kind of already answered that, but we're going to just flesh it out a little bit more. If I wanted this to be positive, the only way to make this positive is to have, well, numerator is always positive. Denominator, if it's negative or 0, well, 0, we have a problem. But if it's 0, if it's negative, we have positive divided by negative, and we'd have a negative. So, no. We need the denominator, which is x, to be positive. So for what x and y values, y doesn't matter. Based on what we see in the numerator, having a hard time talking here too. Based on what we see in the numerator, that the numerator is always positive, we are never, ever going to have a negative numerator and positive denominator under a positive numerator makes it positive. So for what x and y values is this negative? Well, if x was negative, there we go. For what x and y values is the slope 0? Okay, I want the slope to be 0. A slope is going to be 0. A fraction is going to be 0 if the numerator equals 0. So let's just solve. This can happen in your head. Set that equal to 0, so y plus 1 equals 0, so y equals negative 1. Done. If y equaled negative 1, then we would have a slope of 0. Okay? For what x and y values is this undefined? Well, undefined slope is when you divide by 0. There we go. Okay, we're going to stop there and just sort of back up a little bit and talk about a couple things that just happened. Hopefully I won't stammer my way through it. The slope will be 0 when y equals negative 1, but if x is 0 also, we would have 0 over 0. So I'm going to say y equals negative 1 and x cannot be 0. And I want an x and y value where this is undefined. I'm going to start getting a little more specific than I did in the very first problem. I'm just going a little deeper into this whole difference between undefined versus indeterminate, which will be 0 over 0. So for what x and y values is this undefined? Well, x would be 0, but we would go beyond undefined into the realm of indeterminate if the numerator was also equal to 0, which would be y equals negative 1. Okay, let's clarify this. Y can't be negative 1. Sorry, there we go. The denominator can be 0, and if y is also negative 1, we have indeterminate, so y can't be